This is 8.2, multiplying and factoring. So our goal is to be able to multiply polynomials using what's called the distributive property and factor the greatest common factor, also known as the GCF, from a polynomial. So here's what it means to distribute. It means to multiply a term through to all the others. For example, I have a term here, negative 5x. All the others are in parentheses here. And so I'm going to multiply negative 5x times 2x squared. And I'm going to multiply negative 5x times 3x. And then I'm going to multiply negative 5x times negative 8. Notice I put plus signs in each of the places here and here, and then I just carried the sign with the terms, the negative 5x and the negative 8. I kept the sign with those terms. So once I multiply, I end up with negative 5 times 2 is negative 10. We learned from the rules of exponents that when we multiply same bases, x to the first times x squared, we get x to the third. Then I have negative 5 times 3 is negative 15, x to the second. And then negative 5x times negative 8 is positive 40x. Right, factoring. The reverse operation here of what we just did with distributive property. Factor means to, or the opposite of distribute. You pull the GCF, or greatest common factor, out of all the terms. So factoring means to think about all the different things that multiply to equal a term. So in algebra, we have numbers and letters, something like 2y. 2 is what we call a prime number. It only has 1 and 2 as its factors, or numbers that multiply equal 2. So we have 2, and then we have y. And so we would think of this as, just write 2y down here, just 2 times y makes up our term 2y. So we have two separate factors, 2 and y. With 12, we have 3 and 4 is usually what most students think of first. And then 4, of course, can be factored as 2 times 2. So looking at this bottom piece here of what we call the factor tree, which we've worked with before, and the bottom piece of this factor tree, we can then identify what's common to each bottom piece. So you'll notice there's 1, 2 here, and at least 1, 2 here. So that is the greatest common factor. There isn't a 3 in each one. There is not another 2, nor a y. So we have 2 as our greatest common factor. And in terms of what's left over here, it's kind of a division problem to decide what's left over. You can also visually see it from the factor tree. If I were to take 2y and divide it by the GCF 2, I would end up with the 2's canceling and left with y. You'll see that term right here. That's what's left over after I've identified the greatest common factor from the factor tree. So I have a y left over. And here, if I were to take 12 and divide it by 2, I would be left with 6, which is exactly the product of what's left over. If I take here the 2 times the 3, I end up with 6. And so that's what's left over after dividing the term 12 by my greatest common factor 2. Now you can check your factoring by using distributive property. 2 times y is 2y, 2 times 6 is 12. That's going to work whether you've found the greatest common factor or not. So yes, there's a built-in check. It's not going to tell you whether or not you found the biggest term that divides into each of the terms in the polynomial. So you'll have to do some kind of factor tree to make sure that you get the biggest term that goes into each of those. The next one, we have 3x squared and 18x, which would factor as 3 times x times x. 18x is 3 times 6 times x, and then the 6 would be 2 times 3. So just looking at this bottom layer here, the bottom layer here, we're looking for the greatest common factor to each of these terms. So I have a 3 in here. I also have a 3 in here. I actually have 2 3s in here, but only 1 in the first term. So the greatest common factor in terms of numbers is 3. I have an x here and an x here. So the greatest common factor in terms of letters is x. I have another x here, but not another one over here. I have a 2 and a 3 over here, but not another one here. So my greatest common factor is 3x. And you can see I'm left with a x from the first term and a 2 times 3, or 6, from the second term. Let's copy that sign down. And that is factoring out the greatest common factor. All right, we're going to do just a couple of examples here. We're going to distribute here negative x squared cubed times 9x to the 4th would be negative 9x, and then add the powers. 3 plus 4 is 7. Negative x cubed times negative 2x squared will be a positive 2x to the 6th, adding the powers again. And then negative x cubed times 7 is negative 7x cubed. So that's distributive property. And greatest common factor here, we're going to find the greatest common factor between each of these 3 terms. So this would factor as 5 times x times x times x. This would be, so we'll circle that, there's our bottom row. The 25 would factor as 5 times 5 times x times x. And then the 45x would be 9 times 5 times x, and the 9 would be 3 times 3. So here's my bottom row of my tree. So let's go ahead and identify the greatest common factor from each of these 3 terms. We have a 5 here, a 5 here, and a 5 here. I have another 5 in this one, but not another one in the first or last term. I've got an x here, and an x here. And I have an x in the middle term in the first term, but not in the last term. Also, I have 3's in the last term, but no 3's in the first or second term. So my greatest common factor is 5 times x. Make your parentheses. What's left over in the first term are these 2 x's, so we have an x squared left over. In the middle term is 5 times x, that's 5x. And then in the last term, 3 times 3, which is 9. And so that is a factored form for that polynomial. Let's try this one. This one we have a 13. And oftentimes, instead of you can write out all the x's. If you'd like. I'm just going to write out x to the 5th. We know that that represents 5 x's. 26 is 13 times 2, and then x to the 3rd. And here's my bottom row. What's common in each is a 13. And then out of this x to the 5th and x to the 3rd, what we have in common is x to the 3rd. So if I were to split this up, it would be x to the 3rd times x to the 2nd. And let me box the x to the 3rd. So we have an x to the 3rd in the first term and an x to the 3rd in the second. That's our greatest common factor. So we have a 13 x to the 3rd, and we're left with an x squared right here from the first term, and then plus a 2 left from the second term.